Hello everyone and welcome to my YouTube channel The Learning Hub. In the previous video we have discussed about support vector machine. What is the role of support vector machine in supervised learning, how they are working, what are support vectors, and what is the hyperplane. So we know that the ultimate goal of support vector machine is to classify the data sets into different points. So it can be working on multi-class classifier. It is a multi-class classifier which can classify more than two classes also. And basically the separation is done based on hyperplane, which gives a difference. So about this we have discussed in detail in the previous video of SVM. So if you have not gone through it, then just watch that video so that your concepts of SVM gets clear. And in this video we are going to discuss about working of support vector machine in Python. So for working with this, we need to import few libraries. For graph plotting we need matplotlib, we need from sklearn, support vector, and also. So firstly let's import all those libraries. So quickly we will be using those libraries. We have used matplotlib, numpy, matplot for plotting, cvon, sklearn import we have imported, and from this SNS C1 we have imported set the grid style to white grid. Quickly do this. Now we will import the dataset, that is the iris dataset. Iris dataset consists of 4 columns: petal length, petal width, sepal length, and sepal width. Based on these categories, based on these parameters, it classify the various classes of flowers into setosa, versicolor, and virgin. So for that we will load the dataset iris. Let's play a few 7 items approximately to have a look at the dataset. So we can see sepal length, sepal width, petal length, petal width is there, and based on that the species are being predicted. We can check how many unique species are there by using unique command. Rather than working on multiple columns, we will pick the 2 columns, petal length and petal width, for the prediction of species. So we will be using that. So let's use petal length, petal width, and species are imported in call. So now we will pick the location for that location of all the columns, and we will print that quickly. So we can see on the top 5 element petal length, petal width, and species is there, in which we have to work accordingly. So let's have a look at the unique species. We have data into data frames, and we have species column. We will retrieve the unique values from it so that we get to know how many classes will be there at the end. So from here we can see we will be having 3 classes: setosa, versicolor, and virginica, and the data typic object. And an object in Python represents that the data type in this case is categorical, fine, or discrete data type or object, that can be known as. So now next is let's take 2 columns. We are going to make classification based on setosa, based on petal length and petal width that we have imported in here. So call consists of all the 3 columns. Now let's import these columns with the same code. Let's import them into another variable. So we have copied from there and we now picked in call x. Now we can see what is there in this. So we are having only 2 columns in this case. Once this is done, the next thing that we need to do is, as we can see in this case, species consist of setosa, versicolor, and virginica. Now let's assign some numerical values to them so that easily categorization can be done using SVM. So let's give 0 represents setosa, versicolor represents 1, and virginica represented y. For that we will convert them into integer values by writing this code. So label to num, in this what we have done, setosa is represented as 0, versicolor is as 1, virginica as 1. Now what do we need to do next? We will do the mapping. What is mapping? Mapping is used for making iterations. So iteratively working on one by one on each and every record, the setosa will be replaced with 0, versicolor as 1, virginica as 2, and so on. So it will pick from the data frame all the locations of the columns, and then quickly it will convert them into number, and the values will be assigned to y. Fine. So now let's see what is there in y. So we can see these are the values in y. We were having 149 rows approximately, where this 0 is representing setosa, and this versicolor is represented as 1, and this 2 is representing Virginica. So now these are values are represented in the form of integers. Fine. If we look at the beginning of the code, here we were having initially, just a minute, here it was a data type object. Now we have converted them into integer. Now this spaces is being represented as 150 total spaces are there that are of integer type. So now they are in the classification category in the form of integer. So now let's start working on SVM. So from sklearn we will import SVM. Fine. Now this is imported. Now the next is we will train the model with SVM. So here we have set C equal to 0.001. Now let's understand what does this C mean. So basically C is a parameter over here that controls the classification error. So C is basically a hyperparameter that tells the sport vector machine optimization that how much you want to avoid misclassifying each training example. So for if we are having the larger value of C, then the optimization will choose a smaller margin of hyperplane if that hyperplane does a better job of getting the training points classified correctly. Now we can also go with a very small value of C which cause the optimization excuse me, a small value of C will cause the optimizer to look for a larger hyperplane, that is a larger margin of the hyperplane that separates even if that hyperplane misclassifies more points. For very tiny value of C, you should get misclassified examples over often the training sample is linearly separable. Now remember here we will be using in this case the linear kernel. We have linear kernel, we have SPF kernel, and we have polynomial kernel. We have 3 types of kernels. So in this case, from this SVC, we have stored the model in CLF, and we have used the kernel linear. Not here we are not using polynomial kernel or anything. We are simply using a linear kernel in this case. Now we will fit that as we have done in linear regression, logistic regression. So finally, the model is being set. Now as the model is trained, let's get prediction from this model by putting some values. So what we have done over here, we have got the prediction with for the 6th row and the 2nd column. So it will give us prediction. Now we will draw the scatter plot for this, which will represent the classification. For classification, we just need to write the code for scatter plot, that is plt.scatter x dot values for y first column, 0th column, or you can specify the columns names over here, and we will use that C's value is equal to the y, that is mean the value that we have predicted. And you can set the edge colors and all such. It's if you require them, otherwise you can go without these parameters as well. So now we can see that there were 3 classes as we have seen. What were those 3 classes? Setosa, Virginica and versicolor. So accordingly, in this scatter plot, we can see the 3 different classes are being segregated based on the margin. So there is a hyperplane, where the margin is very high, and this is a hyperplane with having very small margin, and based on that, this is the case. And if we change the value of C, this scatter plot will accordingly be changing, because that is the classifier parameter. So now let's quickly draw the confusion matrix for this. Just give me 1 minute. Now let's draw the confusion matrix by using the confusion matrix function. So from sklearn matrix, we will import the confusion matrix, precision score, recall score, and F1 score that can be used to represent the accuracy. Now we will draw the confusion matrix for y train and y prediction, which we are having the values. Just 1 minute. Okay, so as we can say what is to be done in case we have trained the model and we have got the predictions from that. We have seen that. So we will what we need to do over here till now what we have done. So we will get the data into x train, x test, y train and y test, on which the training is to be done with the random factor. We will do the scaling just like we have done the scaling in logistic regression. So we have discussed a lot about that in the previous video, so I'm not going to discuss that in again. So here we have set the model, we have used the model, fit the model. Now let's see what is there in the score prediction. So we, after cross validation to get the average score, we have done cross validation score of the model on the tree. So we have seen that we have done that. And now we will use that model for implementation. First, having a look at the accuracy score. For average accuracy, we have used the NP mean on the score for we have seen the standard deviation and all such things we have done. So in the prediction, we have used the cross validation prediction on the model, and we have printed the confusion matrix by using the confusion matrix function, that is confusion matrix underscore y train function in this case. So y train and y prediction, and for this will give you just the confusion matrix value, and if you want to draw the confusion matrix, that is known as the heat map. So here we will draw the heat map as from C1 library. The heat map function is used on the which will pick the values from this confusion matrix. So whatever is there in the confusion matrix on y train and y prediction, it will draw a heat map for that. So what you need to simply do, we will use the confusion matrix function on the training and prediction, and on that function's output we will draw heat map. So we will set the values true, and whatever color for CMap we want, we will give that. Now when we run this code, we will get this confusion matrix. So here we can see the average accuracy score we have printed over here using NP mean and NP STD, standard for standard deviation. So we are getting accuracy 95% and standard deviation is 5%, and this is the confusion matrix in the case on which the diagonal is giving the true values. That is here it says 39 values of Setosa has been predicted as Setosa, and one value was actually Setosa, and it is also 34 values of Virginica has been predicted as Virginica, and 41 values of versicolor has been predicted as versicolor, because 0, 1 and 2 we have given this value to Setosa, Virginica and versicolor. And there are a few wrong predictions also, that is the having code 1, that was suppose let us say it was for versicolor, so it says कि versicolor of 1 has been predicted wrongly 3 times. 3 times. Similarly for in this case as well. So this is how we have gone with the confusion matrix. So we have seen how this plot is working, how we will get the sport vector machine, in which we are having a hyperplane over here. So we can see the hyperplane line is being drawn, and this is the maximum margin, and the 3 colors are separated. So we are having 3 different classes, and then we have checked the accuracy, and we have drawn the confusion matrix for the same to check the accuracy. So this is how our sport vector machine works. So if you have any doubt or any query, then do write in the chat box. Also, if you have not subscribed my channel yet, don't forget to subscribe the channel and click on the bell button to get the notification on the new upcoming videos, because on daily basis I'm uploading at least 1 video that is very knowledgeable to you for learning machine learning, as well as for theoretical part concepts, as also from practical point of view. So thanks for watching the video.